Okay, so today we are going to look at just a recap, a review of the things that are going to be on this test for solving exponential equations with a common base is one of those topics. So when you do it with a common base, those are kind of the easy ones. You have to, or you get to use the one-to-one property. So on this one, notice that the beginning, there's 8s in all these different places. And I want you to recall, okay, the properties of exponents, that 2 squared times 2 to the third, this would be 2 to the fifth. Remember those rules where you just add the exponents here? It's the same thing, okay, applied in this problem. So this would be 8 to the x squared plus x plus 2x minus 9 power on that side. And on this side would be 4x plus 11. Now that we have a common base, and it's just 1, you see how it's just 1 8 here and 1 8 here? So now I can use that one-to-one property and put the exponents equal to each other. So x squared plus 3x minus 9 equal to 4x plus 11. Let's see, now we need to make this equal to 0. Okay, so we can factor it and solve. So I'm going to subtract the 4x over here and subtract the 11 and make it equal to 0. So this must be 0 right here, okay? Some of you are forgetting to do that step. Now I can factor and solve. And we get 2 answers, a positive 5 and a negative 4. Now, you don't need to check these because on an exponential equation, you can have negative exponents, so that's fine. You know, we checked some with the logs, and we're going to check it in a bit, but this is not one that you have to do that with, so yay. All right, so let's look at the next one, and if you feel like you can do this one, if you want to pause the video and try it on your own, awesome, go right ahead, and then you can come back and check and see if you're right. But I'm going to keep going for those of you that need it. Okay, so on this one, they all have a 12, but notice one of them is not quite 12. This is 1 over 12. So you got to know the rules there for the exponents. If I flip that one, then that becomes a negative 1 exponent on the 12. Okay, and I'm going to just bring everything else down. And this is, remember, a power to a power. So I'm going to put over here, recall. This is what I'm asking you to remember. 2 squared to the third power. This would be 2 to the 6th. So when it's a power to a power, that's when you multiply. So I'm having to multiply this negative 1 times that part there. Okay, so you're having to use those rules of the properties of exponents. Now at this point, we can combine them, make it be 1/12. So it's negative 4x minus 3 plus x squared. This one, it's just the same, we're just bringing it down. All right, so at this point, now we have the single base. You see how we have it the same? We have 1/12 here, 1/12 here. So now I can set those exponents to each other and solve. So I'm going to go ahead and put these in a better order, because this looks weird, right, with the x squared at the back. Again, I have to make this equal to 0 to be able to factor. So I'm going to subtract the 2x, subtract the 3, and something doesn't quite look right. Let me see. What did I do? I wrote the problem wrong, darn it. Okay, you see how this says 2x plus 13? And look, I wrote 2x plus 3. You guys don't do that, right? Okay, let me go ahead and fix it. Add this thing here, because I'm like, that doesn't factor. So I thought that was kind of weird. Okay, so this should be 16 right there. Now that factors. So thank you for bearing with me here to get the right answer. And if you noticed it before me, awesome. That means you're paying close attention. And thank you for that. All right, so this is 8 and negative 2. Now, if you just pause the video and you fast forwarded to this part, you don't even know I made that mistake. So that's awesome too. Okay, so this is our answer. And again, it's exponential equation, so we don't need to check. Okay, so we're good with that. And it's not making a pretty box. And you know me, I want a pretty box. Okay, let's see. There we go. That one's better. Okay. All right, so we don't need to check. Both of those are fine. All right, so now we're going to go on to the log equations, okay? So some of you, for the log equations, most of these you got right on the first part, but I threw them in here anyway because everybody needs, you know, I don't know who needs what. So you fast forward to the part that you need. Okay, so on these, notice that we've got log in more than one place. So I've got, you know, a log here, a log here, a log here. So I have to use my log properties and combine them to have one log at each side. So I want you to recall from our properties of logs that if you have, say, log m plus log n, that can combine to log of m times n. I'm kind of running out of room. Should have wrote that a little bit over. But you write it as one log. When you condense it to one single log, because of the plus, it makes it multiply. So we're using that property right here where we have log of 4 times x plus 3. Other side is just log 8. Okay, so you have to know the properties and be able to use the properties. Now at this point, now I have a single log over here and a single log over here. And since I have the same thing on both sides, I can now use my one-to-one property like we did with the exponents and say 4 times x plus 3, that argument must equal 8. They have to equal each other. It says it is, okay? So now we can solve this. Most of you I've found like to do the distributive property here first, and that's perfectly okay. Doesn't matter, you get the same answer either way. Distribute in the 4. Then we subtract the 12 and divide by 4, and we get negative 1. And even though this is a negative answer, you know how we always check on the logs, okay? So log answers we must check. So must check when we have the log equations. Okay, we can't have, like the argument of a logarithm can't be negative. So all I'm looking at is, let me go to a different color here. I'm looking at what's behind the log. Okay, see how that's got x plus 3? If I plug in negative 1 there, it's still positive, so I'm good. I don't have to worry about the 4 and the 8 because it doesn't even have a variable. So you do have to check it, but this one's fine, so that one works. All right, now we're going to keep going, and I'm hoping this video is working. I'm trying it out with Notability, so this is the first time I'm doing this, so hopefully I don't have to redo it. All right, so this one is a little bit harder. I found this is where some of you needed a little bit of extra guidance. Okay, so we do have log in all these different places, and we need to use our properties. So on the properties, I want you to recall, okay, these properties is that if you have, there's 2 properties here, like if you have log of, or I'm going to put a number in the front, let's put a 2, okay? If you have 2 log m, then that is the same thing as saying log of m squared, okay? So that property says the number that's in the front can go up there as an exponent. So, you know, that's just what it is, okay? You just got to recognize it. The other one that's in this particular problem is like if you have log m minus log n, then when you combine that to one log, it is m over n, okay? The thing that had the negative goes to the bottom. So those are the 2 properties that are being used here in the middle of this problem to solve it. So notice we have a 2 in the front and a 3/2. Okay, so both of those have to be brought back as exponents to the back of wherever the end of the argument is. So it goes with that whole piece. So now we have log base 7 of x plus 1 squared. Over here, log base 7. I'm going to go ahead and combine these two. You see how it's got log base 7 and it's got the minus sign in between? So that's that second property I just wrote right there. So this would be 80 over 5, and then, of course, we've got our power. So I'm just combining that step, so I'm hoping that's not too much for you. Now that we have a single log base 7, and log base 7 is already there, I'm not inserting it, then I can just use my one-to-one property. So now I'm going to have x, I'm going to go ahead and do, well, I'm going to just write the step. X plus 1 squared equal to, this would be what, 16 to the 3/2 power. And you can plug that in your calculator, okay, if you need to. This side I've got to FOIL this, okay, so this would be x squared plus 2x plus 1 equal to, and if you plug this in, this is 64. You do have, or you could do it, just square root of 16 is 4. 4 to the 3rd power is 64. Your choice, okay? But I do need to make this equal to 0, okay? You have to have it equal to 0 to be able to factor. So x squared plus 2x minus 63 equals 0. So you must have a 0 here. So many of you forget that step and start factoring before you even have a, have a 0 in the end. All right, so this factors to, what is that, a 9, positive 9 and negative 7, is that right? Yeah. Yeah, that sounds good. Okay, so that means x could be negative 9 or x could be 7. Now, on this one, again, it's a log equation, so we have to check. So when I'm looking up here, I'm looking at, let me go do a different color here for my things. I'm looking at these parentheses, right? The things that are after log, okay? Well, 80 and 5 doesn't have a variable, so it doesn't matter. But the x plus 1, if I plug in one of my answers and I get a negative there, it won't work. So right off the bat, I know that I have to not do this one, because if I plug in negative 9 in that parentheses for x plus 1, it's going to give me a negative 8. I'm not really worried about the number, I'm just worried that it's negative. So the only answer I have here is the 7. All right, so I'm going to keep going. Now this one steps into the hardest ones. These are the ones people had the most trouble with on the test, okay? Because there was only a log on one side. If there's only a log on one side, then you must rewrite these as exponential to solve. That is the key. Some of you were forgetting that step. Like you did a few and thought, oh, okay, I got it, but then you didn't go to the harder ones on the back, and then it caused a problem. So make sure you know when you need to do something different, and this is one that's different, okay? So notice initially we have log base 2 here and log base 2 here, and that's all we have. So we're going to combine those two using our log properties, so log base 2, because it's a plus, that means multiply, so we have x minus 3 of x plus 1, times x plus 1, okay, equal 5. So notice that's your first step. You're combining that. Now log is only in one spot, so only have it right here, which means I have to rewrite it in the other form. I can't just throw a log on one side and not the other. This is what I'm given. So what is my strategy? I'm going to write it in exponential form. So it's always this base to this power equal to all of that. Okay, so some of you got that backwards. So 2 to the 5th equal to x minus 3 times x plus 1. So once you have it like that, you can just solve your regular equation. The hard part was just remembering how to set it up. 2 to the 5th, if you plug that in your calculator or just do the math, it is 32. Over here, we do have to multiply this out. We get x squared minus 2x minus 3. And again, we got to make this equal to 0. Must equal 0 here to be able to factor, okay? So that's what I'm going to do. Subtract that. That would be minus 35. Yay, and it factors because that would be x minus 7, x plus 5. So we get 7 and negative 5, okay? So now I need to check, especially the negative one. That's the one I'm worried about. So when I look back at these things, the argument behind it, I got x minus 3 and x plus 1. If I plug in a negative or negative 5 in those, would it give me a negative? Yes, it would. So that means this one doesn't work. It's only The only answer here is 7. It's coincidence, it's the same answer as the one above, okay? Don't think they're all answer 7. All right, I'm going to keep going. So if you have this down, awesome, good for you. You can just work the rest and check your answers and, fast forward through it. It's totally fine. Now, notice this one's different, okay? It only has one ln. If you have ln, that means you must use e, okay? So must use the e because the base of the natural log is e. So we don't have to isolate anything. It's already there. So we take the base of this, which we know is e, to this power equal to all of that. That's how you write it in, okay? So e to the 9th power is equal to 2x. And then e to the 9th, remember, that's just a number. It's a decimal, but it's a number, okay? So e to the 9th, now all we gotta do is take whatever that is, divide by 2 to get what x is. And we just plug it in the calculator, and I'm hoping this is right. I didn't double check it. But you can plug it in your calculator. Make sure you know how to do that. If you're not getting this, please let me know so that way I can see what you're doing, especially before you take a test. So either I'm wrong or you're wrong. I don't know. One of us is wrong. We'll figure it out. But we want to make sure you know what you're doing before you take the test. All right, so the next one, making progress here, guys. Okay, so this one, notice we've got log in more than one place. Okay, so I've got log base 2 here, log base 2 here. So I'm going to combine them into 1. And because of the minus, that means I have to write it like this with the division, okay? The x plus 3 has got to be on the bottom. All right, in this point, notice I only have log in one place. So that means I have to write it as exponential. So this base to this power is equal to all of that. I know that looks weird, but that's just what it is, okay? So 2 to the 3rd power is equal to 2x squared over x plus 3. And at this point, you just solve this equation. I know some people still struggle with it. They're like, how do I solve that? Okay, well, you want to multiply by what's on this bottom. Oh, I'm writing the wrong thing. You want to multiply by what's on this bottom. So this is x plus 3. So I'm going to multiply that on both sides here. And then that cancels here, you see? So then over here I have 8, because 2 to the 3rd is 8, times x plus 3 equal to 2x squared. So yes, I know you see it, distributive property. Then we need to factor and solve, okay? So we got to make it equal to 0. So I am going to move the 8x and the 24. I'm going to subtract that on both sides because I never want my leading coefficient to be negative, okay? So 2x squared. Then we have minus 8x minus 24. Now I want to factor this. Well, notice they have a GCF of 2. So I'm going to go ahead and take out the 2 just to make this a little easier. That's always the first thing you should do when you're factoring anyway, is look for a GCF. So now let's see, factors of 12, that subtract to get 4, that's 6 and 2. Yeah, that works. Okay, so that means x is equal to 6 or x is equal to negative 2. All right, I have a negative answer, so I want to check it. So remember, I'm looking back at just the arguments, okay? So I'm looking at this one and this one, okay? Whatever's behind the word log. And turns out the x squared, well, it would be positive anyway because it's squared. The other one, if I plug in negative 2 there, I still get a positive. So these both happen to work, which is pretty cool because that doesn't always happen with the negatives. A lot of times we don't use the negatives because they don't work. But this one actually does work, so wonderful. All right, let's see, last bit, okay, solving exponential equations without a common base. So if they don't have a common base, these are the hard ones, right? If there's no common base, then to solve it, you must take the log of both sides. That is the strategy. That's why they put all these together, y'all. They're all related, okay? You need to know how to do one to know how to do the other, okay? You'll take the log of both sides to, it's the inverse of exponential as log. So it undoes the logarithm. So, and that's what we're going to do. Or it undoes the exponential. So here, 5 and 18 have, they can't be the same base. So we're going to take the log of both sides. All right, so now we did that, because whatever you do to one side of the equation, you have to do to the other. So this is the step. This is your key to solving this problem. All right, and at this point, now we're going to use our properties. That says I can now bring this exponent down in the front. So because it's a binomial, I do have to do my parentheses here. And the goal at this point now is to isolate the x. But because the x is only in one place, you see how I only have one x right here? Then all I got to do is clean it up and get this by itself. So I'm going to divide both sides by the log 5. You can't do this if, on some of these, because it depends on how many where the x's are. And it's just process of solving for the x. So now I got x plus 1 equal to log 18 over log 5. And then subtract the the 1. So log 18 over log 5. And then minus the 1. And I need you to put this in your calculator to make sure you're getting the correct decimal. Because I had some people getting, doing the steps correct, but then they didn't know how to plug it in. And I need you to know how to do that too. So if for some reason you don't get this answer when you're doing your work, see me before you take the test, so that way I can make sure you know how to plug it in correctly. Okay, I'd hate for you to not get the points because you didn't know how to plug it in the calculator. So take the time to do that, and just let me know if you've got questions. All right, we only got 2 left, y'all. We can do this. We can do this. All right, so this one, notice it's an exponential. The key here you need to remember is that you got to isolate the term that has the x. Okay, you got to do that first. Some people are, I don't know, just not doing that for some reason. Okay, so here we would divide by the -2 on both sides. So we get 8 to the 4 minus x equal to 25. Now at this point, that variable is isolated. So now I look to see if I can get the same base. I can't. So now I have to take the log of both sides. So log of this side equal to log of that side. So if you write the word log on one side and you insert it into your equation, you better do it on the other side also. Now I can use that property where we bring down the exponent. Okay, so now this exponent can come down, which is the whole point, so we can solve for the x. There we go. So now we can solve for x. Let's see. I'm thinking it might be good to just divide both sides by log 8. And there's different strategies, okay, that you can do to get to the answer here. As long as you're following your, math rules, your math legal, you're fine. You're going to get the same thing. All right, so, I could subtract the 4, but then I'd have to divide by a negative. So what I'm choosing to do is subtract the log 25 over log 8 and add the x to the other side. So notice I'm just trying to save a step so I don't have to write as much. Instead of moving, the 4, subtracting the 4 and then dividing by -1, I'm going to do the same thing if I just add the x to the other side and subtract the log 25 over log 8. And then, of course, plug it in your calculator. Make sure you're getting the answer. I believe it is this one. If you don't get that, please let me know so we can figure out if you're wrong or if I'm wrong, okay? But that's what it needs to be. Alrighty, so now we've got just one left. Awesome. And this is the hard one. And some of you got this. So if you got this already and you did really good on this one on the test, then you don't have to worry about it. But if you're struggling, you might want to pay attention because this is the hardest one. Okay, so on this one, notice we've got x's in 2 places. This is our key. You see how we got x's and, oh my, what is that doing? Okay, we got x's in 2 places. as far as exponents. But then 2 and 3 have no common base. So step 1, log both sides. All right. Step 2, bring down the exponents. And because they are binomials, we do have to use our parentheses here. Like that, okay? And normally we would divide by log 2 on both sides, but the issue is we've got an x in both places, 2 places. So you got x here and x here. I got to put the x's together. So the first step here is going to be distribute in this number. Okay, we got to get rid of the parentheses. Distribute the numbers on each side, the logs here. So I have x log 2 plus 5 log 2. Over here, I'd have x log 3 minus 2 log 3. So distribute in the pieces. And now, every term that's got an x, you see how it's got an x here and an x here? We're going to move them to the same side. Doesn't matter which side you choose to go on, okay? You're going to get the same answer either way. So if I move, since this one's already positive, I'm going to leave it here. Now I'm going to subtract x log 3, okay, the stuff from the other side. So the 2 terms that have an x are going on one side, and the other terms that don't have an x are going on the other side. And notice I just add and subtract them depending on, what the normal rules are here. And then at this point, the key is to factor out a GCF, or not necessarily a GCF, just the x. That's all I need. Factor out the x. They both have an x, so I'm going to factor it out. Okay, I'm going to take out the x. So factor out the x. Okay, so I take out the x. So now I'm left with log 2 minus log 3. Over here, all I'm doing is bringing this one down. Try not to rewrite anything incorrectly. And now, if I want to get x by itself, I'm just dividing by the thing that is by the x. A few of you had the thing upside. Oh, not sure what happened there. Okay, we'll fix it. Okay, some of you were dividing by the wrong thing. But the goal is to get x by itself. So you divide by what is by the x. All right, so we have x equal to all of this loveliness, which is a little crazy. But all you got to do is plug this in your calculator. Please, please, please check. Plug it in. Make sure you're getting the right answer. Because some of you are getting that step right and getting the answer wrong. I did not double check this answer. Okay, so I'm not sure if this is right. But I'm really hoping it is. So I want you to check it, and if I'm wrong, you let me know. Okay, if I get something different than you get, you need to let me know before you take the test. Alrighty, so we have finished the notes here. And if you have other questions, just please let me know.